Welcome back. We are now doing part 2 of homework number 18, the work with inscribed angles. And so in question number 4, circle K, diameter CD is drawn and point E is located on the circle, such that CE is 16, DE is 30. What is the length of radius of circle K? And show how you arrived at your answer. So I took the liberty of putting in point E, and it doesn't matter where you put it though, although we did say that DE is supposed to be 30, so I made that the longer segment compared to CE, which is 16. And so one of the things we should remember about our inscribed angles, oops, why is it there? So okay, not sure why. Okay, all right. Oops. So put this 16 back there. All right. All right. So if an inscribed angle of a circle intercepts a diameter then it is a right angle. And I'm going to fix that so that you guys can see this a little clearly. But I figured typing it out would be better because my handwriting is atrocious, especially since I don't have a stylus to work from, and until I get a new laptop, which is just not going to happen for any time soon. So we'll just have to kind of work from here. All right, so put little quotations and mark around this and all. And why I put quotations? Whenever I do this and all, I try to make a point that we might use this later on in the proof, or just be able to basically justify why things are the way they are. So we know that in this case, angle DEC is a right angle. So put the little right angle symbol there. And so if that's the case, we're trying to find DC. DC is going to be the hypotenuse of a right triangle. And so that being the case, I'll call it C. We're using, in this case, Pythagorean theorem, a squared plus b squared equals c squared. So a will make 30, so it's 30 squared, plus b, which is 16 squared, is equal to c squared. Okay, so we know that in this case, that 30 squared is going to be 900. And 16 squared is going to be 256. Add that together, you get 1,156 is equal to c squared. Now, we're going to take a calculator, take the square root of both sides, and so c is equal to 34. All right. Sorry. So 34 is going to be the measure of the diameter, but we're looking for, again, always, I recommend, underline the last question. In this case, was the radius of circle K, not the diameter. Therefore, we're going to take the 34 and divide by 2, because we know diameter is twice as long as the radius, to get 17. So here, we get our radius to be 17 units. Okay? So it's quite a bit of work, but not beyond your ability. And the key thing was, remember that when an inscribed angle intercepts a semicircle or a diameter of a circle, then it is a right angle. All right, question number 5. Okay, very complicated looking diagram. In circle F, points A, B, C, D, and E are located on the circle such that the measure of angle C equals 119 degrees. BE and AD are perpendicular, forming the right angle. Determine the measure of arc AE. So again, we're going to kind of focus on this arc here. Okay, so the funny thing in this case is that let's see what we know about the other information we have here. Right, so we want to figure out how we get the arc. Now, it could be, in this case, we could find the measure of angle ABE. So here, if we do that, notice how angle ABE is the inscribed angle that intercepts the arc there. To do that, however, we would need to know how to find the angles of angle ABE. Well, here's the thing. We know that triangle AGB is here, and that angle AGB is a right angle. Not only that, we remember that the measure of angle BAD and the measure of angle BCD add up to 180. Now, why is the case? We talked about before in previous problem that if a quadrilateral is inscribed in a circle, here, which quadrilateral? Well, AB quad A, B, C, D. If the four vertices are on the circle, then the opposite angles must be supplementary. Well, okay, so if they're supplementary, then we know angle BCD is 119. And that's to measure angle BAD. We're going to subtract 119 from both sides. And we're going to get, in this case, the measure of angle BAD is equal to 61 degrees. And so here is 61 degrees. Well, okay, that would mean that angle ABG, measure angle ABG, is equal to 180 minus 90 minus 61. Well, 180 minus 90 is 90, and then 90 minus 61, that will be giving us an angle measure of 29 degrees. So we know angle ABG is 29 degrees. Because here, another triangle we're focusing on here, triangle ABG, has also 180 degrees. So, that being the case, we can now use the measure of angle ABG is 1/2 the measure of arc AE. Well, that means, and if we multiply both sides by 2, that the measure of arc AE is equal to 2 times 29 degrees. And that will give us an angle measure of, arc measurement of 58 degrees. So here we had to, it seemed like there was a lot of different things, but the first thing we want to focus on is if we're dealing with arc AE, we want to see which inscribed angle intercepts it. And maybe we find that angle measure. We should be able to help find the arc that intercepts it. And so here we also have to use our knowledge of when we have a quadrilateral that's inscribed in a circle. In this case, we call it a cyclical quad. So here, the idea is that opposite angles of a cyclical quad or a quad that's inscribed in a circle will be supplementary. And that's how we found angle BAG, which of course helps us find angle ABG, which is the angle we're going to use to find the measure of arc AE. Okay, so we have 2 more questions, and I'll leave that for part 3. So at this time, please, if you have found this helpful, please make sure that you leave a like for the video. Please leave questions and comments below in the comment section. And of course, if you have any other questions about any other geometry type of topics you want to cover, please leave them in the comment section below. Then I'll be able to possibly make videos of those things. The key thing is hopefully that all of these things are helpful to you in your learning about geometry. All right, thank you so much for watching. I appreciate it. And of course, take care and be safe. Look out for part 3, which covers the last 2 questions.